We made it to school. Safe and sound. Safe and sound. So ready to learn and get these questions answered that I need. I got a nice close parking spot, so that's good. I don't have to walk too far. Whew. I like my fit.
Class.
I'm tired, girl.
Wait, no, EKane. Hold on. I'm gonna need some math help. No, I'm being dead.
What class you taking?
Listen, I'm getting in the nursing program, okay? Mm-hmm. It's all these ratios and percentages.
You in stats?
Yeah, basic. I just started, but it's also the
Girl, you don't even know what class you're in.
Girl, look, I don't like math. I literally went over there and cried with the tutor. I was like, yo, this is stressful. I literally was just traumatized because I don't like asking questions. I don't like asking questions.
I might can help you. Cause bitch, I'm in calc. That's throwing me. It's tearing me up today too. Tearing me the hell up.
I can't do that.
What's your name?
Ty-Asia, or you can call me Ty.
Ty. Oh, I think you already got. Wait, what's your Snapchat name?
Underscore yo, it's Ty.
Hold on, let me.
Or what? No, it's just Ty is mine.
Oh hey Ty.
Mm-hmm.
Oh hey Ty.
Oh hey Ty.
Oh hey Ty. Okay, bye then. Okay. I got some good calories in today. I think I'm at 2,500 calories today. All I do is eat. Ain't that what I'm supposed to do? I am carrying a load. Okay, y'all, don't be in class acting up, for real. This is the last class before midterms, bitch. That's why I'm so stressed today, because I don't play about math, y'all. Like, I did not, like, my brain forgot all the shit we learned in the beginning of the semester. I'm so irritated. So I needed to just refresh my brain and make sure I'm studying and getting things done. Good thing I got my extra smoothie. Thanks for the gifts today. Hey Queen, I was in the elevator, so it's pretty laggy. Give you that one gift that scares the hell out of you that one time. I got my volume low. Somebody smell good as a bitch. Who is that smelling like sex? What's that? What that smell? What that smell?
Your message, Andrew. Did you get it? Because I just got an email saying that you totally didn't get it. Okay, I didn't get an automated response this time. Might take a second for it to actually make its way through. you know, a few days to kind of work on some of the problems in the practice exam. I think there's, you know, good mix of sort of on the end easier problems and on the end harder problems. But of course, that's sort of like my opinion, right? So this is where I'm gonna go ahead and ask, like, are there any problems from the practice exam that we should do together? Like, I think of one, but yeah, Erica?
Number 2.
Number 2.
I second that motion.
Okay. So, number 2. Any other ones?
Yes.
Okay.
Number 2 and number 11.
Number 11.
Oh, I lied. And number 5.
Yeah. And number 5. So 5 and 11? Or
Mm-hmm. Both of them. 2, 5, and 11.
Can we do 5 but after? Like 6 foot forward. Like we find the area and then try to do work on it. I know it's not asking for work, but
I mean, sure, I guess.
thank you.
There's like no units on it.
Oh yeah, there's not. Never mind then.
We can do 4 if you want to. Or we can do one of the other work problems from the practice sheet.
Okay.
Is that an okay yes or is that an okay?
Okay, practice sheet.
Okay, practice sheet, okay. Any other ones? No? So 2, 5, 11?
3.
8? Which one's 8? I wasn't looking. Okay, sure. Yeah. And last call. 2, 5, 11. Yeah, Diego.
9C.
9C. Sure. It's gonna be more than one way of doing 9C though, as a heads up. As is usually the case in these examples.
Mine goes 9D.
Who smokes cigarettes?
9E?
D.
No, 9D. Okay.
Oh wait, no, that's not the one. So it doesn't get record. I meant 10D.
10D.
That smell like Chris. That's so disgusting.
Sure.
It's so trifling.
Okay.
That's trifling.
It's what? 1 minus cosine cosine. And 0 to pi. And unless I read the instructions too quickly, this is area between curves. Okay. I do need to sketch a graph here.
These go up to 2 and down to -1.
Okay.
Your lines go 1, or up to 2, and only down to that. There's a little on there.
I always just go to the side and write down what my parent function is and what it looks like. So when I come over here and I graph 1 minus cosine, I know that I want to shift this thing up and then reflect it. So it's up 1, 2. What's this thing look like?
Looks like negative cosine plus 1.
This. Where does it go? It goes to cosine, or, yeah, 0, 1, okay. And then we're going to pi over 2, let's do that. So cosine pi over 2 is 0, so this is that 1, and then this is 2. Looks something a little bit like that. And then cosine is that. Made by -1 a little bit too high. Something like this. If my brain is working correctly.
Looks good.
So area in between these curves is going to be this area and this area. And I look at this particular thing and I see 2 different sort of regions. One on the left, one on the right. And whenever that happens, we are singularly interested in this intersection point. So sort of a step 0 here, we want to find that intersection point. Which means I want to set these 2 graphs equal to each other. 1 minus cosine x equals cosine x. Solve trig equation, add cosine to both sides. Divide by 2. Use our knowledge of inverse trig. We want the arc cosine of 1/2, or we want an angle in the first quadrant of cosine that gives me 1/2. What angle is that, out of curiosity?
Pi over 3.
Pi over 3. And we're going to be using that in our integrals to find this area, because we're going to be getting the left area and the right area separately in that. So let's go ahead and write down our integral for the left area. We're integrating from 0 to pi over 3. Doing big minus small, so my big here is cosine and my small here is 1 minus cosine. So we have cosine x minus 1 minus cosine of x dx. And plus integral pi over 3 to pi. Big minus small again. My big here is now 1 minus cosine, and my small here is cosine. And let's start combining things and writing out and integrating. So we have what? 2 cosine x minus 1 dx plus pi over 3 to pi of 1 minus 2 cosine of x dx. I'm going to integrate each of these term by term. So 2 sine of x minus x. Evaluate from 0 to pi over 3. Plus x minus 2 sine of x. Evaluate from pi over 3 to pi. And let's start plugging in and evaluating. So plug in pi over 3, we get 2 sine pi over 3 minus pi over 3 minus 2 sine of 0 minus 0 plus pi minus 2 sine of pi minus pi over 3 minus 2 sine pi over 3. Let's start distributing some negatives, I suppose. I see here a sine of 0, which is 0, another 0. I got a sine of pi. What's sine of pi? 0. And I think that's all the zeros, or at least it's all the zeros I see. I got pi. I take away pi over 3. I take away a second pi over 3. What do I have left over? If I have pi minus 2 pi over 3? Pi over 3.
Oh, yeah.
That one, that one, that one. And I have altogether 4 sine of pi over 3. What's pi, sine of pi over 3? Square root of 3 over 2. I got 4 of them, so overall I got 2.
Wait, the 2 gets carried inside the root. That side 4 gets carried inside the root, and you take it out?
No, the sine of pi over 3 is square root of 3 divided by 2. So we have 4 divided by 2. Yeah, I suppose technically we have that other 0 here that I didn't draw a line through, but it just about accounts for everything. So I'm getting pi over 3 plus 2 root 3. No? Wrong or just
Oh, no,
different?
you're probably right. I agree with that.
At what point did we start to differ, Sophia?
Mine was from the start.
That's unfortunate.
I don't know how, but I have mine backwards. I don't understand.
Your graphs or?
No, the 1 minus cosine x minus cosine x, I had that before
So you
cosine x
had,
minus
you
1
had
minus
these
cosine.
switched around.
Yeah. No, I had a, technically, yeah.
Technically,
I'm
yeah.
wondering, will it matter? And the answer is, I think it's plus in the center, so probably not. But
I think it will.
notation, it will matter if it's negative.
Yeah, I think you're gonna get a negative area here if you do that.
To be fair though, I did also have an answer of -4, so.
That's also kind of bizarre. There is a way to get 4 here, right? But I suppose the biggest things to remember is big minus small. Our big over here on the left side is that cosine. 'Cause that
I
one was-
think you said at one point. I just must have done it incorrectly. That one.
Got the concept correct, wrote it down wrong.
Set it wrong?
No, I'm just echoing what
Oh.
I was trying to say. He knew that's what he was supposed to do, but he wrote it backwards.
That's my guess.
Okay on two?
Yes. Now I am.
Braylon doing all right?
You said on power 3 is square root 3 over 2?
Yes. Okay, so that gets us to 5, and the one that is, in my opinion, the hardest problem.
Number 5 is?
That's my opinion, but yeah.
Well, I believe you.
I did this one in class.
The volume of the frustum of a cone.
Yeah.
Yeah, I don't know nothing
That
about that.
one's, I consider that one to be the hardest.
Yeah, I cheated on that one.
Right, because every other frustum I think we've done had numbers and we can sort of make educated guesses about those. But this one's like totally general.
Yeah.
And like the other like weird things like me and Stuart, the author of the textbook, had this thing to do with. Like the textbook like the red enumerated problems, like one Stuart thinks is solving ones. And this one's not even random.
This is the basic thing that one student should be able to do this so that they are.
I feel insulted.
No, I'm joking.
So let's see here. We have frustum of a cone. We have no numbers here. Only arbitrary constants. Because like I think in there's a work problem that I think I can have you guys do that had a frustum of a cone. But you could sort of intuit that the geometry of this frustum was such that it was half like the total height of like the actual cone that would make it. We have no such physical intuition here. It could be half, it could be a quarter, it could be anything. Okay, we have no idea. This is a volume of revolutions problem. Which means we do kind of need to decide discs and washers versus cylindrical shells. I am of the opinion that in this particular case, discs and washers are going to be the way to go. In particular, instead of doing a washer, we're going to have a disc washer.
Lord have mercy.
Now, little r is taken, big R is taken. So I'm going to use R tilde for my representative slices radius.
Is that Java?
What?
You said.
R
Turbo
tilde.
Joe. Turbo Joe, yeah.
Okay, we'll move on. And I'm also going to set, my sort of 0 point to be at the base of the cone. So this right here, I'm going to call that distance y. This is my variable height from the base up to my representative slice. Now, in my opinion, the largest portion of difficulty for this problem comes from what on earth is R tilde? That's my opinion, because it's complicated. Right, Flip? Yeah. Right, because we're going to be integrating the area of this thing, so it's going to be pi R tilde squared. And then we integrate that from 0 to h. Interesting. Pi r tilde squared.
R in terms of Y.
Yeah, we need to get r tilde in terms of y. We will eventually have similar triangles here. I'm going to take my little sideways cross-section-y trapezoidal shape looking thing, and I'm about to embed it in the plane. Here?
Yeah.
Now, if we were to use similar triangles, I would probably like to actually complete this triangle from the frustum. And if I were to use similar triangles again, that would mean that I kind of want the entire height of this triangle. And this is where a little bit of knowledge from algebra comes back. If I imagine this thing as a straight line, this particular point here has a very special name, the y-intercept. And for a straight line in the form of y equals mx plus b, that would be b. If we're going to be solving for b here, that probably means that we kind of want to know a point on the line for y and x. We also kind of want to know the slope of this line.
Use the triangle H.
Yep. Right here, this point has coordinate pair RH. And here, this coordinate pair has point R0. What slope? Is that rise over run or run over rise? Rise over run. I always ask that question. I always phrase it in the same way just to see how many people say that it's run over rise. Rise over run. So, I'm starting up here, I'm going down here, my change in my height, I'm going down is a negative h. I'm still going to the right, I'm starting at r, I'm ending at big R, so it's big R minus R. Good?
No.
Now,
Wait, redo how you got H again. What you just do?
rise over run.
It's going up H.
That's if you go to the left, right? This line is going down.
Oh,
It's got negative slope.
okay.
Right, or if we like plugged in everything, we'd have 0 minus h,
Mm,
and then big R minus little r.
you got me.
And you always read graphs lexicographically. People have heard that word, right? Lexicographically. It's how you read books, left to right, up to down. It's an ordering. And that ordering for left to right, then up to down is lexicographic. Fancy words, fun facts. Yeah, Xavier.
I have a dumb question.
Okay.
Would making another triangle help here? Because we have RH, R0, and we also have H, R. Does that make sense? Oh, sorry, RH. Big RH. Does that help? Because you can, I don't know, reflect
That point?
Yes.
not sure that would be helpful. My intuition says no, but I'm happy to be proven wrong. My intuition says I don't think that would be terribly helpful.
I was trying to think of doing stuff with angles.
Yeah, because we want this distance,
Yeah.
right? And then this triangle, I don't think really realistically gives us a whole lot of information about that distance.
Yeah, I'm just trying to do side angle side. No, that's
Side angle side would be what case for law of sines?
yeah, I'm trying to do sine stuff to get that length, but that doesn't work.
I mean, you know, that's our one, let's see if it does work. I don't know. My intuition says I don't really see how that would work. But
Yeah, that's
I'm
probably
happy to be
best
proven. So we got M. We now need a point, a coordinate pair for Y and X. We do have two convenient choices. One of them is a little bit more convenient than the other. We got this one, or we got this one. Which one do you guys think we should do? What do you?
The R0.
R0, not because 0 is an actual number, but because it's 0. 0 is a super nice number to plug in. So we have 0 is equal to my slope times x plus b. If we chose this other one, then we'd have a little r over here, and then we'd have an h here. We'd have to do some combination stuff. Add this stuff over, and we get our y-intercept. My height is negative hr over r minus r.
Wait.
Well, it's not positive.
You mean positive, that's not each other.
Oh, yeah. Duh. I added this thing up.
Also, it's not really having negative on the top part of the bar.
I agree. It's not impossible if little r is the bigger of the two, but that's just totally in fine contradiction of what the picture is drawing.
We would have set up.
So now you can integrate that whole thing, but minus the integral from h to hr over r.
Remember, what we're going for is r tilde.
Yes, that's not integrate, but similar kind of the whole thing.
Yeah, we're about similar triangles this whole thing. And I didn't write down my y from over there. All right, my similar triangles are here. And here. All right, on the big triangle side, I'm gonna put big R up top, and then I got the height, H big R over R minus R. This thing is equal to, now I put my little one, so my base is R tilde. I'm gonna make this green, just so that we can keep track of the thing that we're actually trying to solve for. Divided by this height of the triangle, which is going to be a big minus small of the big height, take away y. So hr minus r minus r minus 1. And we can solve for r here. Doesn't that look like fun? It looks like super fun, right, Blake? Again, this is why I say this problem is sneakily difficult. Lots of simple manipulation, so I'm kind of interested to see what we got.
I feel like you're doing it the hard way. I'm just completely wrong.
I don't know, I guess we'll find out once we take a look at the answers and see if we got different things. I'd be more than happy if there's a super like easy, like really clever way of doing this. Let's see here. HR over R minus R minus Y. R multiplied by reciprocal. Okay, let's do some canceling out here. I got an R here and an R there that I would like to cancel. And then we can do some more distribution. I'm going to multiply R minus R, big R minus little r, divided by H over here. I got an H up top, that's going to cancel. I have a big R minus little r, that's going to cancel with that one. I'm just left with that big R up top. Not really a whole lot to cancel here. This thing is equal to my R tilde. Diego, how we doing? Erica? No?
I just don't even get you.
So where did I lose you?
Huh?
Where did I lose you?
What are you? So this all this equals R with the thing over it.
Yeah, R tilde.
Oh. Okay.
Right, we're solving this thing for R tilde, and this thing came from similar triangles. So we flip this thing over for the reciprocal, then we multiply this thing over.
Okay.
I have a question.
Yeah, what's up?
So maybe I'm seeing things like you know, but not that we can right? Y left over R Y. So my fraction that you cancel everything is. Thank you.
Here.
Yes.
Okay.
And then RY. So over on our other side, we're left with R minus a fraction of Y. Does that make sense?
Maybe. This big R, that big R, they totally cancel, right?
Yep.
Okay, so
I
we're
don't feel-
distributing this in.
Distributing that. It's big.
Right, like how we would do that.
Yes, yes. I'm just seeing H R squared on top, and then you leave the fraction alone, and then you're left with an R, HR.
Point, come up here and point.
Okay.
I have no idea.
Yeah, because I don't know that R either.
So we're multiplying this with this guy, right?
Yeah.
So I'm thinking we're left with an R squared, and we're going straight across.
Remember, this whole thing is being multiplied.
Yes, but, so you have R. H R squared. Minus Y, I guess.
that R squared come?
No, not R squared yet. But when we distribute, it's gonna turn into R squared. You cancel out the R that's on the bottom here.
This is
And then
being
it's gonna be left.
subtracted by little r. You can't cancel a subtraction. with
Yeah,
multiplication.
yeah. So it's just gonna be left alone. So you're just gonna have R squared at the top.
Where?
This is over R minus R, minus R, and then that minus Y. This is distributing goes to Y. So this is distributed like that. And showing it this multiplication and this Y. No, am I crazy?
Oh, so you're not canceling these.
I don't see cancellation.
We got
Maybe,
this big R on top, we got that big R down below.
Oh, okay, I see. God, I'm just crazy one, I think.
Right, like,
Maybe.
that R squared that you would have is gonna get canceled down to a R anyway from this. It's gonna happen.
It's gonna happen. I'm just not.
Before you do the multiplication, you can simplify the left side
You can.
ratio before you do that, and you wouldn't have that confusion at all.
Yeah, but I'm just doing it one step at a time, you skipped a couple, so I got confused.
Skipped a few.
I think you skipped a few, at least in my head.
Well, I can't skip it to it, kind of, but.
Kind of. 2 arrows is not doing full distribution, but it's okay. I think I'm caught up. I think I'm caught up. Continue, sorry.
Like, that would have concerned that I did it wrong.
You didn't do it wrong. It's just, you skipped a lot of steps that you normally
You
go.
simplify a lot of steps.
Yeah. You probably did it right, I'm just confused.
That's what I got.
I feel like I'm crazy. This is what you got.
I did all of that in like one simple step.
Yeah.
Now I wanna see your simple set.
Please.
Okay.
What on earth did you do to get that?
So, literally this is just the disk method, where this is your shape, it's a trapezoid, and then it goes like this, where this is big R, this is little r, and then this is h. And then, so you could say that there's like a representative slice that's equal to r tilde, and
But you flip this thing on its side now.
yeah.
So
it's
your
still gonna-
representative slice would be going up and down.
It'd still give you the same volume as what you're doing.
Yeah, but
just
this would be like cylindrical shells method or something.
Not really, because all you need to do is find the slope of that line, which is, or yeah, it'd be like that.
Okay, there we go.
But,
Something happier.
So it's the integral of 0 to h. And then your pi. And then this is where the slope of your line would go, square. The slope of your line is, so y equals big R minus little r over h x plus r as your y-intercept. And you plug that in there, and you integrate that. So you're taking this, the x is wherever, like, x is wherever the input is, that's your, like, y value. And it's the same thing as yours, because yours is the same graph, except you're starting up here. Like that.
This is gonna be a question, and I'm sort of curious how you're gonna answer this. what made you want to flip the frustrating like that?
Just because it's circles, so if you can get anything to revolve, then it's easier to do that than right triangle stuff.
Yeah, but what about that geometry told you this is going to be easier from the outset? Right? Because presumably you had not done this when you decided to do this. Right? Because chronologically this came first. Right? So what about this screamed at you that this is going to be easier?
I could see, like, when I looked at the question, I could see that there would be a slope of a line if you set this to be your x-axis.
Okay.
And so, since I'd have the slope of my line, and then y-intercepted, assuming this is my y, then I can just use the disk method and evolve it.
It's not, it was like when I first looked at this, when I came in today, I was thinking what he was thinking, actually.
That is faster.
Not necessarily faster, it just doesn't.
Like, I mean, it's faster, but like, I can only think that it's faster after having seen it, right?
I just.
And
like,
that's where I'm coming from, is like, I do not see from the beginning of this. Like, I totally agree, this absolutely looks easier, but I can only see that it is easier after the fact. I'm trying to get the, where was this before the fact,
I
right?
thought
I
this
saw
was
art
pretty
Toby
easy.
as a change in art.
Yeah,
And because it's like a change in art, that's when I started thinking this method.
okay.
I would say this is the easy part, like, I don't know, I just kind of thought of it, but the integrating is kind of weird.
And the integrator is just gonna be a U sub, right? Or you could multiply this thing.
Yeah, I multiplied it out,
Okay.
but yeah. Oh, yes.
That was a bit work.
I mean, it probably does. Like, I don't see anything like systematically wrong with this. The only thing that I don't see is like how you would know this is easier before doing it. Right? Like that's what I don't see, right? Like I would not look at this and go, oh yeah, it's trivial if I rotate it, but only the right way in the right direction, and then embed it into the XY plane as well.
You know,
Right.
right, to rotate it in the right direction, you could do it from the other side, can't you, with big arms or X-intercept?
Yeah, that's what he's doing right here.
And this is like where, like my question to you, which I sort of still feel a little dissatisfied with the answer, is like, by the time I even drew this, right, my brain was going, we're doing similar triangles. We're setting this up for similar triangles. Right, so I'm going through that process. Right, by the time I've even got here and I've written down my slope, I'm going, I got this triangle, we're doing similar triangles. And I'm not like stopping in the middle of this to do rotation and more embedding.
Really? If it's circular, I don't know. I just try to find it.
I mean, that's what we're doing, isn't it?
Yeah. Like, seeing the slope of the line.
it's great intuition, like, do not get me wrong here, and it looks totally right. I'm just wondering where on earth it came from. That's where I'm coming from. So like, I want to
it's
get
a
that. That's what I'm
trapezoid.
trying to understand. Yeah.
So if you rotate a trapezoid, you
It's a trapezoid.
I
I totally agree. It's still a trapezoid after you rotate that. Now, like this is a case of like I'm trying to ask a question for me to get right, right?
Mhm.
I would never think to do that because by the time I got to the point where I would think of that, I'm already here.
I don't, like, I see where you're coming with the X and Y coordinates on that. I think it's hard to grasp.
Okay.
So I just try to find another way, and that's the first thing I work on.
But I mean, you'd still have like X and Y coordinates over here, right? Like,
Yeah.
bam.
I'm more looking for like the it's gonna be in this range. So that's your R minus Y. And so that's your yeah.
I mean, because they're rotated, that R minus R would be my denominator, my run,
Yeah.
right, as opposed to my runs. No, I guess I just wouldn't think to do it that way.
Why do you have a circle while you're doing it? Or something?
Well, because I look at the trapezoid, right? And I go, I'm gonna need to set up something to figure out this length. Now we're going for like a length of something inside of the trapezoid or inside the triangle, we do simple triangle. Okay. So I was looking at this geometry here. My brain was filling in the triangle up here, and that's where my brain went to use the triangles. All right, my brain didn't look at this, flip it this way, and then add X and Y axes. Right, all my brain did was complete the triangle. So that's sort of like what I'm kind of asking about, like, is there sort of like a general circumstance where don't use triangle, make function graph instead? I don't know, I look at that and I see a triangle. I know they're equivalent in the end, but I look at that, I see triangle.
I feel when you are.
I mean, we do get,
And like,
I don't know, when you start having to add shapes, when you start having to add extra functions. it's not fun.
it's the same function.
Speaking of adding shapes and functions, I do have a question on this, but it's like a, do you think it would be any way easier kind of question?
Okay.
If you did take it and make it a box and then minus the negative space, the triangles are on the sides, would that be easier potentially?
I have no idea. I imagine finding like the negative space there would be easier if we did cylindrical shells.
Yeah, definitely for shells. It would be terribly
so
difficult.
maybe, I don't know.
Because it's just,
You're asking
For a
me
square times
what
h.
is easier, right? And for me, I don't find symbol manipulation hard. Right? So for me, I look at that stuff and I go, oh, that's easy. That's just symbol manipulation. Who cares about that? Right? For me, what I find truly hard is the geometric intuition here. Right? Because with enough practice, like anybody can be good at pushing symbols around a page. right? Geometric intuition, like that's something that you either have or you don't have, right? So, for me, for my subjective view of easy, I kind of don't find this that bad. Right, it's sort of getting here, that's the bad part, the geometric intuition, it's hard. So, I don't know, as far as easy. Is it doable? I imagine so.
We'll try after class.
Yeah. But, well, this kind of went a little bit longer than what I kind of anticipated it would. I just kind of want to like pick your brain apart on that. Yeah, what's up, Sophia?
Okay, your point of similar triangles is to find your little squiggle arc, right?
Yeah, to find the radius of the disk.
The radius of your little squiggle
Yeah.
arc. And is there like problems where similar triangle is like only gonna work?
Yeah, and you're asking me like this really big, grand hypothetical of all problems in existence.
Like on tests.
I don't know.
You don't know? Because like I've noticed you, well, you only show us like similar triangles.
Because it's what I think of.
Yeah.
Right?
So it's like,
You have to understand, like, there is an implicit bias going on here,
okay.
right? And that implicit bias is my implicit bias. Like, I look at these things because I have been trained to do so. I see similar triangles everywhere.
Okay.
That's just been my training.
And they work?
Yeah.
Okay.
Right, this is why, like, even in sort of like computer graphics, we still use triangular modes for everything. Right, like Link's face in Ocarina of Time had like 17 triangles overall, whereas now if we compare it to like, I don't know, Claire Obscure Expedition 33's Gustav, he has a couple billion triangles on his face. It's all still triangles, there's just more of them. Yeah, Xavier?
So, for something more rounded or something that doesn't perfectly make a disc all the way through, do you think the method that like you used here would be better? Say you have I don't know, a vase, but that vase has an empty space, and you want to fit behind the empty space in between like the walls. Would making two functions.
I mean, it's still gonna be like a circular cross section, right? Right, so that's still gonna be discs and washers. How you get your radius is like totally up to you. And that's where me and Blake have done kind of analogously similar, but also like totally different things, have gone in like divergent paths. Right, for me to get the radius, I went through similar triangles. For Blake to get the radius, he embedded the shape and got a slope, and then used y equals mx plus b. So it's all about getting that radius, right? It's still going to be discs and washers at the end of the day. Yeah, Zach?
This is gonna be a question away from all of this.
Okay.
Problem 4, you had a work problem.
Yeah.
Is that set up the interval? Are you gonna give us the unit conversion for like?
Yeah, when I made the practice exam, I totally forgot about that.
Oh,
So it didn't make it on the front page.
but on an exam.
You will have it on the actual exam.
Okay, look at this.
Okay, I'm looking at this. The
I
answer
didn't-
looks right.
Okay, but yeah, I didn't integrate nothing. I just started with the big minus small.
Where did these come from?
Comparing them over here, like triangles, the triangles that are over R and then big H minus H. I just didn't draw the triangles out.
So you're still doing that.
Yeah,
You just didn't actually integrate this thing.
yeah, I just started with the actual volume.
I mean, I suppose that works. I might have to go change the exam now for the volume problem and say using calculus.
Okay. Okay.
At the risk of seeming a little bit callous, I still want to pick your brain apart. Okay with this one? Now we've seen two different ways of getting the radii.
Let's try a third.
Try a third.
Okay.
11. 11? Oh, okay, yeah, the improper interval. 0 to what, 5?
Next one's 2.
Okay, excellent. All right, so improper integral, it's a vertical asymptote improper integral, so we're going to split this up into 2. We want from the left and right side my vertical asymptote at 2. 0 to 2, x over x minus 2 dx, plus 2 to 5, x minus 2 dx. And let's see here, I want to integrate this thing, so I'm going to just take one of these.
Why did we do that?
So when you have a vertical asymptote, you have to split it up because you can't integrate across that.
Right.
Yeah. And we're going to do these one at a time. And the second we're able to write anything that says this thing is divergent, we're going to stop because it's divergent. Oh, this is a mean one. How are you integrating this thing? U sub? Okay, what's your U?
X
And my du then would be dx. So I get limit. I'm gonna have to change limits, aren't we? Let's see here. Integral, we got u down below, du here. What are you doing about that x up top?
Well, I was gonna say that it's 2 plus u,
Okay.
but it's no problem.
Let's see here, let's plug in 0. We get minus 2. Let's plug in 2 here, we get 0. So we're going to have that one be our little dummy variable here because we can't divide by 0. So limit now as b goes to 0 from the left. So how are you integrating that thing?
Just use up infinitely until it works out at some point.
Can I make a suggestion that use algebra instead?
Okay.
You have addition up in the numerator now instead of subtraction in the denominator.
You can split
You can split the fraction. Yep. So we have 1 plus 2 over u. Split this into u over u plus 2 over u, and then u divided by u is 1. And then let's integrate this thing. I get u plus 2 natural log the absolute value of u. Let's go ahead and plug in our limits. We got b plus 2 natural log be minus -2 plus 2 natural log of the absolute value of -2. Absolute value of -2 is +2.
Did you say you were getting values with changing absolute values last time?
What?
I don't know, I feel like you changed absolute values early, what was that, last week Monday? And it ended up going wrong from changing the absolute values early.
That, if I remember what you're talking about right, was if we did these both together
Okay.
and then tried to combine their limits after the integral.
Okay.
Right, we're taking this separately, one integral at a time. Because the only way this thing converges is if this converges in its own right and this converges in its own right. So on the supposition that it is convergent, we got to do this anyway. On the supposition that it is divergent and we're expecting this one to diverge, then this is the quickest route to claim victory. Either way, we got to do both. Let's see here. B goes to 0. This goes to 0. We get a +2 here. And then a -2 natural log of 2. And we just have this thing. I'm taking the limit of this thing as B is going to 0. What's the limit of natural log as the input goes to 0?
-infinity.
-infinity. We got a -infinite. What does that mean for this integral? Diverges. Which means this integral diverged, which means this integral diverged.
Question.
Yeah, what's up?
Backs up at all for x equals -2. Oh, wait, you get 0 right there, if that's the case.
Yeah. Zach.
Yes.
Here, I wouldn't have done use of. I would have added and subtracted by 2 in the numerator. And that would get us 1 plus 2 over x minus 2. Then I don't have to fuss around with limits. And we still get a divergent integral at the end anyway.
For method, same result.
Yeah. And that's why I'm like gonna learn to be okay with spending like 40 minutes on this thing. So that I can think about that. Different method, same result. Goes both ways.
Well, whenever I integrate or depreciate around the x-axis, I always imagine the shape. So that is the shape that we get up in.
I mean, yeah. Again, like, I don't disagree with its correctness. That's never been the question there. Right?
No, I'm just saying because my thought process was, hey, that's a change in R from bottom to top. And then I saw like, hey, that's like in a graph that would look like
Okay.
dissing washer. I don't know. I'm just saying how I saw that as a potential way of solving it.
And I just kind of went off the picture. And I saw like, oh, my
You
discs
saw
are
it
sideways.
Yeah.
And then I saw the triangle. All right, so that's problem 11. It diverges. You found one of the parts of the integral, that particular part diverged, whole thing diverged. Yeah, Emily?
So if you did the -2 plus 2, it would be 1 plus 2 over x minus 2?
1 plus 2 over x minus 2, yeah.
Okay.
All right. 8. 8's the midpoint rule one, right?
Mm-hmm.
This is one where it's kind of nice to actually have a picture. Well, I mean oh yeah, it's got 12 ticks.
Oh, does it?
Right, it has ticks at every half.
It does.
Sorry, Blake, I'm erasing the picture. I'm erasing my picture too, if it makes you feel any better. Let's see here, we got that kind of shape-ish. Alright, so we want midpoint rule on this thing. We're estimating. So we're gonna do like lots of estimations here. I see tick marks at every half. And what that's telling me is that if I double that, I want my rectangular widths to be 1, because then my midpoint can be at that half. So let's see here, it's 6. Yeah, half of 6 is 3. My triangle, or not my triangles, my rectangles. Look. Little something. Like this. Area of rectangles length times width. Right, Sophia? What's my width of all of these? 1. Now I want my lengths. So let's see here. This is where we're going to be starting to estimate it. So let's see here. This is 1, 2, 3, 4. This is maybe like halfway between 4 and 5. So we can call that 4.5. So 1, 2, 3, 4. That's a bit closer to 5 than what the other one was. So I'm gonna call that maybe like 4.8 maybe.
Okay.
That's,
Kind of like guesstimating here. What's up, Xavier?
I don't know why, but my eyes looked at the 1 as at 5 instead of the 1.5 at 4.8.
Your eyes went what, here?
Yes.
Okay. Yeah, we're over there. Here we're at what looks like slightly below 3. I don't know, maybe like 3.8. Or not 3.8, we're below 3, so like 2.8. So now we're here, we're slightly above 2, so maybe like 2.2. So shows you how well I drew my picture. It's nothing like what's over there. This is at
3.6.
3.6. Ish. Let's just ignore the scale here. And this one's at like, I don't know, maybe 3.2-ish.
Sure.
Yeah, I did not draw that thing well. It's fine.
Is it drawn? That's good.
Is it wrong? Technically, yes.
Drawn.
Drawn. Oh, yeah, it is.
Is it drawn? Yes, that's good.
So let's add up all of these areas. We got 4.5 times 1 plus 4.8 times 1 plus 2.8 plus 2.2 plus 3.6 plus 3.2. Let's see here. 1, 2, 2.1. 8, 10, 12, 15, 18. And about 20.1-ish.
Yep. 21. I don't know.
Is that what you got?
Yeah, calculator wise, 4.8.
Did I count this wrong? 1. I did, okay. I didn't do my decimals right.
It is kind of trash.
21.1. I forget who asked about 11. Or not 11, this is 8. Good with 8?
Yeah, wait, if the one, or if the 6, you're saying were like 2, you divide them by 2?
Multiply.
Almost.
Okay, because area of rectangle is
Oh,
like
yeah, yeah,
times
yeah.
9C. All right, I think this was you, Diego, right? What do you try?
I did trade sub.
All right, I would say that should work. Where did you get stuck in your trig sum? This is what, sign substitution?
Yeah.
Oh, and we even have limits here. How generous. dx is cosine theta d theta. Lower limit, upper limit. Plug in 0 here, sine is 0. Plug in 1 here, sine is, that's what theta is 5/2. Let's do all of our substitutions. How are we doing, Diego?
Yeah, I'm with it too, yeah.
Okay.
And then, the one on the sine squared turns cosine.
Yep, cosine squared.
Cosine
Take the
squared.
square root of
And then
cosine
multiply them in terms of sine cubed,
Cosine squared.
Yep.
So is this the part where you went?
Yeah, cause then I was like, can I do the power reduction for cosine squared? But then that's when I just like, yeah.
No. We have an odd number of signs. I want to say the sign.
Okay, that's what I was
For
thinking as well
yourself.
too, but I wasn't sure if we, okay.
Yep. So I want to make this sine squared theta, cosine squared theta. We're going to save a sine theta. And then I'm going to use Pythagorean identity for this one. Make this into 1 minus cosine squared. And this is for u sub, right? U is cosine. That's why we save that sign. I do need to put in a negative here, so let's just put that outside. Lower limit is cosine of 0, so that's going to be positive 1. Upper limit is cosine pi over 2, so it's going to be 0. And then we got 1 minus u squared du. Okay, you gotta go? Do you can take it from there?
Yeah.
Okay.
You said you said also or something.
Oh yeah, this is absolutely another one that like u sub with first replacement would work. Right? U is 1 minus x squared. Du is negative 2x dx. Negative 1 half du is x dx. And let's see here, x squared is 1 minus u. So let's see here, plug in 0, I get 0, plug in 1, I get 0. So this will become 1 half the integral from 1 to 0.
Oh, negative on like it, right?
What?
It is negative 1 half.
Oh, I guess I just forgot about that negative. Let's see here, this is root u. Du. I'm just trying to make sure I didn't forget anything else.
What I was asking though, if you pull a negative out of the whole integral, you can make the bound 0 to 1 again, yeah? Or no?
Yeah, if you want to. I've usually found that introducing that rule tends to make students think, oh, we can just flip the bounds no matter what. And that's what we want. And then I go, but now you need the negative, and then they go, like, now I just. So I usually don't. That's all about it.
Okay.
Okay, repeated linear factors.
Those tend to check that.
Is this just a case of like forgot what to do with a repeated linear factor?
Yeah, I feel like we add an extra variable and then have the original linear factor and then that squared, but is that right? I don't
Yeah.
remember. Okay.
At least if I'm like understanding what you're saying. X minus 3, x minus 2 squared. So you'd set it up kind of like that.
Okay.
You want to go through that one, Xavier, or do you feel like you can take it from there?
I would like to because I don't fully remember matrices if you have time.
Sure, we got time. All right, let's multiply it straight through by all these denominators. We get x squared plus 1 is a x minus 2 squared plus b.
You don't have an extra, no, you don't.
Plus c x minus 3.
Yes, okay. Yeah. I feel like it's this simple term that always messes me up.
Good so far, Xavier?
Yes, you just boiled, yeah?
Yep.
Yeah.
Before you go further.
It's +4, yeah.
Okay. X term, or X squared term, so we get 1 over here. Equals A plus B.
Wait, yeah, you just would.
And then, let me mark them off as I go. It's that one, that one, that one.
Oh, you're doing the x squared is equal to 1.
Yeah, I'm doing their coefficients.
And then you do the
The
other one
x's.
equals to 0.
Yep. So negative 4A, negative 5B plus C. And then 4A plus 6B minus 3C. Equals 1.
Yeah, okay. At this point, just to make sure I remember this right, we're going to equal it so that one of the denominators equals 0. So we'll have a 3, we'll have a 2, and we'll have another 2, unless I'm wrong on that.
That's only when they're unique linear factors.
Okay.
In which case, you wouldn't have even gone past this step. And you wouldn't have done any of this. You would just have plugged in those
Up there.
values.
What is unique linear factors mean?
So these are non-unique linear factors. Right, they're all linear factors, right? We don't have any like irreducible quadratics shown up in the denominator. But we do have a repeated linear factor.
Okay, so
That's
that
going to make
was
it non-unique.
x minus 3, x minus 2, and x minus 1, then we would have.
Then you would have unique linear factors, yeah. Right, the second one of your exponents becomes something other than 1 is the second this is no longer unique linear factors, both in and outside of parentheses.
Okay.
Yeah, Diego?
So you couldn't just plug in X to cancel them out to find easier?
No, I mean, if you plug in X for X, I don't think anything's gonna change.
Like for like the 8, the 2, and all that stuff, or that just don't work out?
What, here?
Just in, like in general, like to like the unique way, like you said, we
Yeah.
can just plug in X. So if you plug in like a 3 for X, it'll cancel out the B
No,
and C.
that's-
Yeah, and then you can still get A, right? But the problem is you're still gonna need to figure out B,
Okay, yeah.
right? And to figure out B, you're still gonna need to do something like this.
Okay.
And if you're gonna go through the work anyway of getting to this point, you might as well just do this.
Okay.
Because it's not like we're actually gonna be solving the system, we're gonna be asking calculators in the system. Do you remember how to plug it into your calculator, Xavier?
I'm gonna find it. It's in
Okay. Called Plsmlt 2. PLYSMLT 2.
2, and then simultaneous equation solver.
Yep, you want the simultaneous equation solver.
This is 3, 3, and
Yep, 3 unknowns, 3 variables. Yeah, what's up?
When you're making the denominators, if you have something squared, you split it up into, so like how you did x minus 2 and x minus 2 squared. Would it ever be a case where it's like cubed or something like that?
No. And this comes back to sort of theory of polynomials from like grade calc. Any polynomial of any degree can be factored into linear factors or irreducible quadratics. So you're never actually going to get like an irreducible cubic, right? There's going to be some way of factorizing that cubic into either irreducible quadratics or into linears.
And then if that was the case, how would you split up the two values?
Before or after the factorization?
After.
After the factorization, I suppose it depends on what you have. Right, if it's 3 unique linear factors, then you want to do a x minus a.
Or no, I meant like if one of them was cubed, like repeated.
Oh, like this?
Yes.
Then you do a over b squared c. One for each power as you go.
Okay.
It did end up.
So hypothetically, could we have that same problem that we started with,
Uh-huh.
but you change that x minus 2 to an x squared plus 2?
Okay, so if it were a irreducible quadratic, you'd put a linear up top.
Well, would you still split it up into the x plus 2 and then the x plus 2 squared?
So this?
That quantity squared, the second quantity squared. No, so that's still there,
That's not.
and now that's squared. Yep,
So we have a repeated irreducible quadratic.
yes. Okay.
You do that.
Oh,
Sort of the same kind of behavior as the linears, it's just that you got instead of a constant on top of another.
So once you get the matrix done, you have filled in and then you can just differentiate.
Yeah, A, B, C, then you integrate through by term. You're gonna get lots of natural logs.
Yep. And the log rules, you want us to memorize them and simplify, or is it okay if we just leave the logs?
You just leave the logs, that's fine.
question.
That's okay.
Okay? Okay? Like, okay? Still on. I want to know you did. I want to know your thought process. Right? Exam on Friday. And I think what I will say at this point, this is a case where there are 2 lines, and there needs to be some reading between those 2 lines. Wouldn't it be crazy? Wouldn't it be crazy, right, like with GDSU's fall break coming up next week, Monday and Tuesday? Wouldn't it be crazy if something were to happen to me over the weekend, class on Monday happened to be canceled? Wouldn't it be crazy?
That would be crazy. I would
That would
be
be
devastated.
crazy.
I'd have no idea what to do.
We'd have to go, we'd have to skip this class.
That'd be crazy.
I
I sure hope that doesn't happen.
And we probably have to skip class.
Yeah.
Do you have the answer for that question?
For the throw down, sort of, yeah, I can kind of like recognize it and see it. But I think you're saying.
How do you do stuff?
Oh, we done. I need to study my pussy off for the next 2 days. Seriously. I hope you get exact questions with the same numbers so I can just memorize the answer. Like I usually do. If he throw even one number off, it's gonna be a problem. Because I'm not gonna know what the fuck is going on. She a teacher? That girl look like she 10 years old. I'm finna take a shit. I did just eat 3,000 calories. And I feel some pressure on my pussy. So let's go ahead and get in this bathroom and do what needs to be done. My damn back is killing me.
I'm saying like, you got this going on. This is a lot. You just had like, you're the asshole. Are you okay? I'm good, but I genuinely like care for you. Like I think it's a lay down. Yo, can you as you can? I don't know. Like, yeah, as you can. I love you, rest. I'm not tired. That was a lot. Like usually I'm a character. I didn't know what the fuck to do, bro. Come here, Sean, come here. It's a rug in there. That was funny.
Thank you, Jim. Okay, we're all set. Okay.
Bye. I love them. They're so sweet and patient with me. I'm saying you should go home. No, I'm not saying like whatever. I'm saying like you got this going on. This is a lot. You're the asshole. Are you okay? No, I'm good. But I genuinely like care for you. Like I think it's a lay down. Yo, can you as you can? I don't know. Like, yeah, as you can. I love you, man. That was a lot. Like usually I'm a character. I didn't know what the fuck to do, bro. No, come here, Sean. Come here. It's a rug in there.
Ooh, I should give me some Subway.
Mona was not scared or instigating. Well, she was instigating a little bit, but mostly she was narrating because Mona saw that fight coming from a mile away. I've been watching the Joe Budden podcast ever since Mona has been on it.
I'll take your point at 0. -1.
No?
Oh, it smell like chicken quesadillas in here. Oh.
You got swim shorts and stuff, and we go swimming or something? No?
My brain hurt. Then I gotta wash Mommy's hair. I'm not washing it tonight. Nah. I'm gonna go ahead and wash it tomorrow. Because I don't have class tomorrow. Yeah, I'm gonna wash it tomorrow. Oh, I've been saying it the whole week. I know. I know. Them streets, they fold them strong. And bitches gon' fuck just because money long. Just know that I know. Boy, you know it, I know it.
You got a boyfriend that's even too much for me, bitch. I'm not even gonna lie. Telling some niggas, that's like when a motherfucker slide up and you open their DMs and shit and you tell them like, I got a boyfriend and no, bitch. Nah, back over there with dude. I don't get no fuck. They be, oh, but I said I had a boyfriend. What you mad at? You shouldn't have even allowed this nigga
Out of your request, bitch.
on phone and grade. You opened his request and let him in, folks, on BD. And then said even you had a boyfriend. No. On phone him. No. Ain't none of that on phone and grade. I want my bitch to slap the shit out of Floyd security for walking up on her, folks, on BD.
Bitch ass nigga, who the fuck is you?
Do I look like I fuck with niggas, bitch? Woo, tweak on his ass on phone. Don't be like, I have a boyfriend and, cause bitch, you was screaming. We don't know what the fuck that bitch would have said if them cameras run rolling, and no cap probably know that. That's why he probably tweaking with the bitch on BD. He probably like, bitch, you did. I know you. You did that because you was already live on.
Now, y'all know Dominique Morgan is scared of me. Because why would I block Dominique? Every time Dominique make a video about me, he has me blocked because he already know. He already fucking know. Now, you know. Now, y'all know Dominique Morgan is scared of me. Because why would I block Dominique? Every time Dominique make a video about me,
do you know it's a whole different section you could go out of?
He already fucking know.
What the fuck is they doing?
Now, you know. Now, y'all know Dominique Morgan is scared of me. Because why would I block Dominique?
Why is this car not
Every
going
time
around?
Dominique make a video about me,
So
he has me
motherfucking
blocked
dumb.
because he already know. He already fucking know.
Girl, I was here
Now,
first.
you know.
The fuck?
Now, y'all know Dominique Morgan is scared of me. Because why would I block
time, all this
Dominique?
dumb
Every
ass
time
shit y'all
Dominique make a
doing.
video about me, he has me blocked.
My 27-year-old woman found out real early on that being with an older man means getting both lips kissed on regularly. I'm talking about all that. I'm talking about in there. I'm talking about all the love you can get, baby. I just want love on you. I just want to appreciate what that last nigga did. I'm talking about all the love.
I'm talking about any.
Feeling the world go against us. So we put the work.
And she got a half day tomorrow, so that give you more time to wash it too. Wait, why do it say at 8 p.m.? What the fuck is they talking about 8 p.m.? That's more than a damn half day. That's at 1.5 day. Maybe it's a typo, honey. Oh, dismissal at 12:25. A half day tomorrow and Friday. What the fuck they got going on? Oh, well, Chris will be off work, so. Well, I will